Sir, my name is Bolas Abhishek. I'm from EC department. Course title Communication Systems. Today's topic is about innovation of switched capacitor voltage multiplier. Introduction to switch capacitor voltage multipliers. Switch capacitor voltage multipliers are essential circuits used to generate higher higher voltages from a lower voltage source. The utilized capacitors can bandwidth switches to transform charges and multiplying voltages efficiently. Innovation in the area aims to improve efficiency, reduce and enhances performance of various applications. Introductions to switched capacitors. A switched capacitor is an electronic circuit element implementing a filter. It works by moving charges out of capacitors. When switches are opened and closed, usually non-overlapping signals are used to control the switches so that all the switches are closed simultaneously. These are the switched capacitor voltages multipliers and integrated circuits capacitors. Parasitic capacitors are also associated with an integrated, and it is SI substrate layer. There will be forming a layers like layer 1 and layer 2, so that these are the integrated circuit capacitors. The next topic is about basic principles of switched capacitor circuits. These circuits operate by periodically switches capacitors between different voltage levels. Charges transformed during switches results in voltage multiplications or division. This simplicity of capacitor switches makes the circuit suitable for integration into compact systems. An introduction like capacitors. A switch capacitor SC is an electronic circuit elements implementation. A filter, it works by moving charges into and out of capacitors. When switches are opened and closed, usually non-overlapping signals are used to control the switches so that all switches are closed simultaneously. This is also integrated circuit capacitors and parastatic capacitors associated with an integrated. These are the basic principles of switched capacitor circuits. The next topic is limitations of traditional voltage multipliers. Convertible designs often suffer from high ripple and voltage ripple fluctuations. Power efficiency can be limited due to switching losses and parastatic effects. Scaling these circuits for higher voltage can introduce reliability and stability charges, and these are the limitations for traditional voltage multipliers. And it is ripple and voltage ripple fluctuations, and it is scaling these kind of circuits for higher voltages includes reliability and stability challenges. These are the traditional voltage multipliers. Recent innovation or switched capacitor multiplying design. New topologies incorporate to adaptive switching schemes to optimize charge transfer. Use of advanced semiconductor devices reduce switching losses and improves efficiency. Integrations with the digital control system enables dynamic adjustments for varying load conditions. Is the switch capacitor modification. In power conversions, pulse derive circuits transmit to the pulse of controller generate to the power transistors. Driver circuits must both transmit and control switch on off signals with galvanic isolations and prove energy to them the switch and the off and to the main required on the off stage. The required energy increases with the power transistor input capacitance which is transistor modulation. Thus, when these are the dis- design ideas, and it is also the circuit require high power designs for typically parallel the power transistor. These are the switch capacitor multiplier designs. The next topic is about novel switching techniques for enhanced performance. Implementing synchronous and asynchronous switching algorithm minimizes ripple and noise. Multiple phase switches schemes distribute charge transfer, eventually reducing stress on components. Adaptive timing controls help optimizing efficient under different operating conditions. Like it is also design ideas for the novel switching techniques. Adaptive timing control helps optimizing efficiency under different operating conditions. Multiple phase switching schemes discrete charges transfer easily, eventually reducing stress on the components. These are the techniques for enhanced performance. The next topic is about material and components innovation. Development of high Q capacitor reduces energy losses during charge transfer. Use of wide band gap semiconductor enhances switches speed and thermal stability. In power converter pulse drive, also circuits transmit the public controller generates to the power transistor, derive the switches on and off signals, galvanic isolation and provide energy in the components, and the required energy increases with the power transistor input capacitance, which also increases with the power that transistor module manages. Thus, when the circuit requires high power design, typically parallel the power transistors, increasing the input capacitance when you need to operate IGBT, including data gate bipolar transistor modules in parallel. It is best to share the gate. These are the material components innovation. Application of advanced voltage multiplier circuits. These innovations enable use in portable devices requiring high voltage from low power sources. They are utilized in medical imaging equipment such as X-ray generators, and a high voltage power supplies for industrial and aerospace applications benefits from these improvements. The student must be able to analyze how clampers are used to increase the converters the AC input voltage into DC output voltage. Increment the components used in voltage multiplier circuits. Construct a circuit below that AC sources. This is the example of advanced voltage multiplier circuits. Challenges Challenges for future direction. Managing parasitic becomes more critical as circuits for miniaturized. Ensuring stability and reliability, long-term operational remains on focus. Future researchers aims to integrating smart control algorithms, novel materials, and future enhancement. These are the in the future directions. Challenges for future directions. Managing parasitic effects. It is a design ideas for the reader solve design problems. It is also challenges and future directions. Ensuring stability and reliability over long term operation remains a focus. Future researchers aims to integrate short note short note algorithms, materials, future enhancement. It is a over long term operational remains a focus. Summary of key innovation: adaptive switching and control techniques significantly improves circuit efficiency. Material enhancement reduces losses and supports higher voltage operation. The evolution of switched capacitor voltage multipliers expands their application scope. These are the adaptive switching and control techniques improves crucial in the circuit efficiency. Material advance advertisements reduce losses and support their higher operations. The evolution of switching capacitor voltage multiplier expands their application in the scope. Thank you.